Okay, madam. We can start.
Okay, sir.
Okay, madam.
Okay. Om Namo Venkatesaya. Good morning, Honorable Joint Executive Officer Srimati S. Bhargavi Madam, Devasthanam Educational Officer Dr. Ramana Sir, respected Principal Madam Dr. P. Dr. T. Meena Kumari, HOD of the Statistics Department and Webinar Convener, and respected Vice Principal Dr. P. Kumari, HOD of Home Science Department, the inspiring and intellectual research assistant, Dr.Shaik Nafeez Umar, Assistant Professor, Department of Statistics and Computer Science, SV Agricultural College, Tirupathi, Dr. B.Muniswamy, Professor and Chairman, Ph.D. Department of Statistics, Andhra University, Visakhapatnam. I extend a gracious welcome to you all on the eve of National Webinar on recent developments in statistics and our software applications. The platform has been initiated with the support of Joint Executive Officer Srimati S. Bhargavi Madam, who is more energetic and motivates us with new strategies of excellence through advanced technologies. We are very blessed to have Dr. Ramana Prasad sir as our Devasthanam Educational Officer, who always inspires us with enhancing activities and consistently focus on the student, teacher, and institutional development. We could not have pulled off to this webinar without the hard work and dedication of Dr. K. Mahadevamma, Principal, Dr. T. Meena Kumari, HOD Department of Statistics, and Webinar Conveners. We proudly confess and zeal and enthusiasm they always shows in undertaking challenging tasks and work tirelessly to achieve it. Now we start the webinar by prayer. Prayer by K. Padmini, Lecturer, Department of Commerce. Ramanamamu Janmarakshaka Mantram Ramanamamu Janmarakshaka Mantram Kamasamuyaka Bhajimpave Manasa Ramanamamu. Ramanamamu. Thank you, Padmini, giving a good beginning to the webinar. Now I request Dr. K. Mahadevamma to address us with the need of statistics. She is a professional social worker with 25 years of teaching and training expertise. She involved in vast extension activities and made a difference. She is more energetic and practiced the right work at the right time. She is a role model to all of us, and I express my gratitude for her in building positive, motivating, and engaging environment. Ma'am, please address the platform. Speech by Principal Madam.
Om Namo Venkatesaya. A warm good morning to everyone. Respected Joint Executive Officer Sada Bhargavi Madam, Devasthanam's Educational Officer Dr. R. Ramana Prasad Sir, Honorable Resource Persons Dr.Shaik Nafeez, Umar, and Prof.B.Muniswamy, I welcome you with a great pleasure to this national webinar on recent developments in statistics and our software applications. Organized by the Department of Statistics, SPW Degree and PG College, Tirupathi Devasthanam, Tirupathi. I deem to invite all the academicians, students on this platform. Today, statistics are important because we live in the information world and much of this. Information are determined mathematically by statistics help. It means to inform the correct data and statistics concepts are necessary. I could confidently say that webinar will bring out more information and useful to academicians, researchers, and students. I wish this webinar organized by the Department of Statistics a grand success. Thank you one and all.
So thank you, ma'am, for your splendid address. Thank you very much. Now I request Dr. P. Kumari, Vice Principal of SPW Degree College, to address us, madam. Please. A brief introduction about our Vice Principal, Dr. P. Kumari. Dr. P. Kumari, Professor and HOD of Home Science Department, Vice Principal of SPW Degree and PG College. She has 30 years of experience in teaching and extension activities. She has published more than 20 papers in both international and national journals, and she also published 2 textbooks for home science students. She is actively participated in many administration and co-curricular activities of our college. She worked Deputy Warden and Warden of SPW Degree College hostels for 7 years. She is also a member of BOS, SVU University in Home Science, SV University, and also in Vikram Simhapuri University. She is recipient of 2 awards, namely Bharat Mahila Shiromani, and another one is Mother Teresa Award. Now I request you, madam, please address the platform. Thank you, madam.
Om Namo Venkatesaya. I would like to say a few words on the importance of statistics and day-to-day life, using proper methods to collect the data and employ correct analysis and effectively present the results. It is a crucial process behind how we make discoveries in science and make decisions based on the data. Statistics allows us to understand the subject much more deeply, and it keeps us about what is happening around the world. The statistics is important because we live in the information world, and I would like to thank the Department of Statistics, faculty members, Srimati Meena Kumari, Dr. K. Srinivasulu, Dr. M. Pushpalata for organizing this useful webinar to all the sections of the people. So I wish all the best. Thank you.
Thank you very much, madam, for your brief address. Now over to Pushpa.
Good morning to everyone. I am Pushpalata, faculty in the Department of Statistics. Now I request Dr. T. Meena Kumari Madam, HOD, Department of Statistics, BOS member and webinar convener. She is a professional worker with 29 years of teaching and training expertise. She involved in vast extension activities and made a difference. She is more energetic and practiced the right work at the right time. She is a role model to all of us, and I express my gratitude for her in building positive, motivating, and engaging environment. Ma'am, please address the platform.
Thank you, Pushpa. Good morning to all. Respected JEO Madam, S. Bhargavi Garu, respected DEO Sir, Ramana Prasad Garu, respected Principal Madam, Dr. K. Mahadevamma, respected Vice Principal, Dr. P. Kumari, honorable resource persons, and dear participants, a warm welcome to you all. First of all, I congratulate my faculty members, Dr. M. Pushpalata, Dr. K. Srinivasulu, who had done immense work in organizing the webinar with the support of the management. The main motto behind organizing this webinar on recent developments in statistics and all software applications is to create awareness on the modern all software applications. Hope this webinar will enrich the statistical professionals, research scholars, and students. Before commencing the seminar, I would like to say a few words about recent developments in statistics. Basically, I belong to botany department and did my research in biological science. In my research work, various statistical tools have been used for the analysis of research data and research design. All the early stage of research, our biologists were applying basic statistical tools such as univariate statistical tools, namely measures of central tendency, measures of dispersion, correlation coefficient, etc. At present, various advanced statistical tools, namely multivariate statistical tools, have been developed and applied in biological research with the introduction of recent advances in computer technology. Several statistical software packages have been developed for data analysis. Some of them are SPSS, SAS, StatLab, GenStat, Minitab, RAGS, etc. Data science is a broad field that refers to the collection, processes, theories, tools, and techniques that enable review analysis and extraction of valuable information and knowledge from raw data. With these few words, I request the resource persons, Dr.Shaik, Nafeez, Umar, and Prof.B.Muniswamy to deliver talks on recent developments in statistics and all software applications. Thank you.
Madam, request చేయండి madam. Now I request Dr.
Now I request Dr. K. Srinivasulu introduce the resource person.
Om Namo Venkateswara. Good morning to all. Welcome to the invitees attended today's national webinar conducting in SPW Degree and PG College, Tirupati. In this connection, it is my pleasure to invite Dr. Shaik Nafeez Umar as one of the speakers for this webinar. Dr. Shaik Nafeez Umar is Assistant Professor in the Department of Statistics and Computer Application, SV Agriculture College, Tirupati. He worked on GenPack, EMRI, App Labs, and Computer Science Corporation as a data scientist. He was specialized in advanced econometric models and brought out many research findings in this broader context. It is academic excellence, SAS, SPSS, Minitab, eViews, SYSTA, or programming, and GRETL is high recordable. He published nearly 75 papers in national and international journals in authorized 4 books for his credit. He participated in various seminars, workshops, and conferences, refresher courses, and orientation courses. Hope the view brought in the discussion will enlighten with recent development in statistics and all software applications. Thank you, sir. Thank you. Sir, I request to you invite the section for your speech. Nafeez Umar, sir, please take.
Okay, thank you, K. Srinivasulu.
Thank you, sir.
Thank you. Okay, so first of all, good morning to all. So this conducting a webinar, SPW Degree College. So I'm audible, all of you?
Yes, sir, you are audible.
Oh, sir. Okay. So before going to introduction of R programming, so nowadays, so many packages or programs are available, and particularly statistics. So earlier, so it has only for some, so there is a C++ and Fortran semantics on in earlier days. So later on, the statistical packages are developed already. Madam, principal and madam told there is a different statistical softwares available in market. that is one of the major the contribution of SAS, AIR, SISTA, Minitab, Grital, so many packages, statistical packages. So so 1 decade, in this particular statistics, so many developments are there, particularly for the packages, programming and packages. So R is one of the leading. So last year to 2018-19. So now the first place is occupied. There is Python and R. So both are the programming. It is a free software programming languages are available. Okay. So in this first session, so I'm going to introduce R programming and so how install R programming or the program, and as well as the simple the basic statistics, and also we are going to do some descriptive statistics, correlation, regression. It is very simple actually to say. So the layman can be understand and easy to understand and easy to operate. So that's why most of the people so attracting are. This is the first slide, and this is my content. So today, we are going to discuss introduction to R. So basically, why R? So people why are attracting R, and why people are switch to R. So earlier, so they have only some SPSS, some different packages are there. So why people are moving and switch to R programming? So that is very important. Particularly the research oriented people who are working in the research centers, who are working and research students, as well as the academicians also. And in the statistical part, I'm going to describe also how we operate apply the distributive statistics functions in our graphs also. It is very important for a graphical representation, for having any data, any numerical data, everything, and the correlation, simple linear regression, multiple linear regression. If I have time, I'm going to take one small case study that is called advanced statistical technique, neural network model. Is a case study. So this is today's my session content. So the here in this slide, I'm so given us some of the facts and statistics, figures. So what is the facts here? So Google, one of the world's biggest the website Google uses R to calculate so return of investment. So for advertising the company, so is a R place is a major role for the calculating return of investment. And also Ford company. So you people heard about the Ford company, the user to how to improve the design on its vehicles. Okay, so it is purely the vehicle company, that there is a Ford company. So what is the role of R to improve the design of its vehicle? It is very interesting, I think so. What is the relationship between R programming versus the design of its vehicles? Same as Twitter uses to R monitor user experience. So how many people they have? So how many people are searching? So what is the topic? Everything. And the Food Drug Administration to simulate test a new food and a new drug, Food and Drug Administration. And so US National Weather Services to predict severe flooding. So earlier, so I have to see in so last Hyderabad. Okay, so weather conditions, weather forecasting, it is very important. It is a big task for every government. So if you have past data or previous data or historical data, so can we predict weather parameters? So yes, definitely. So we can predict. So at a 95% confidence level or a 99% confidence level. So it is required only for the past data. Past data is a weather data, it is a morning data, evening data, whatever may be. So once we have data, definitely, so can estimate with the help of R, that is our programming. Same thing, human rights data analysis group uses R to quantify the impact of R. And are you being used the New York Times to create infographics? So these are I'm giving the few things that is facts and related R language, R programming languages. Okay, so Comes to what is R. So everybody, what is R? R is a regression, or what is it stands for R? It is a simply the two authors created, two authors, so Ross Ihaka and Robert Gentleman. So both are starting the word R and R. So created. Their first name is R. So that's why so they name it as R, capital R. So that is R language sometimes. So nobody knows about what is R stands for. Okay, so the interesting thing is in a Google search for advanced analytics software. So one of these, so this R programming. So everybody says to R. What is R? What is R? And used more than 2 million people worldwide. It is amazing, 2 million. So last I heard about in 2018, 2017, that is only 1.2. So latest, so last 2 days back, I searched something. So Google, the platform, so there is 2 million people worldwide. So it is very great, I think. So most used data science language after Python. Python is one of the leading, next followed by R. Okay, so these two programs packages is a free installation. It is a open source. It has a rich package, so repositories with more than 12,000 packages are available. 12,000 packages. Packages is nothing but it is inbuilt packages are available. So if you want to some advanced graphical representation, one package is there that is called a ggplot is there. ggplot2 is there. If you want to artificial neural network, neural net is there. Neural is there. So these are the some of the packages. So if you want to, so for example, I'm going to predict some advanced statistical and forecasting techniques. That is called ARIMA or multiple linear regression, cluster analysis, factor analysis. If you want to factor analysis, you go by install some packages. Already it is available. So Google. Okay, so these are the RY everything. Now it is very interesting. One of the survey is conducted. So last, I think, so this was 2018. There is a trend source marketing research. So which do you prefer to use? So the major, the trending and current the software packages languages are available in market. So simply they taken the top 3, that is SAS, R and Python. So that time to I'm talking about 2008. This is information. This is statistics. 40% of the people so prefer to R. Next, followed by 34% SAS, statistical analysis system, and 26% of the people Python. So this is only the respondent 1048. It is a small the sample size. There is a respondents. Okay, so I'm audible.
Yes, sir.
Okay. So if you're having any problem, so let me know. Otherwise, can you send me a message? So I have it phone. Okay,
No problem, sir.
Okay, so these are the some of the information. So why so every people talking about R, Python, SAS. So in particularly in BTech students, MTech students, and research people. Okay, so they heard about the talking about so data science nowadays. The trend, the certain name, data science. Okay, data scientist. Okay, so I'm figure out some of the basic things. So you people know about so why people. Now this is R by industry. This is one of the very interesting. And here the industry wise. So here I'm giving the left side academic, healthcare, government, consulting, insurance, energy, finance, retail, and media. So these are the some groups, some areas, some domains. But almost all the academicians are close to 80% they were used, which is to R by industry. So why only academicians? Next followed by healthcare. Academicians are having data, or they are research people. So every month, every 2 months, they submitted some article publications, everything. So they have data, the experimental data. So that's why the people are interesting to use to academicians. That is 80% of industry. So these are the percentage of industry. Okay, so this is interesting thing. So academicians and healthcare, and next followed by government, everything. This is R by industry. Now comes to the companies uses of R. It is one of the interesting thing. So look here. So the Facebook already used to R. Facebook, also Google is there, and also the big shot company Deloitte is there, IBM is there, Chartered Account. So these are the few things. So there is a Bing is there, one of the research such website is there. So these are the, some of the companies using R. So that is a it is a plays role, the big role. So the various companies. So we don't know. So where we use in Paytm or so they want to know about how many the customers are there. So the customers are using their Paytm applications. So how many users are there? Transactions in bank transactions are there. So everything they maintain and they analyzed with the help of R. So Capgemini is there, food companies there, Bank of America. So in top 10, so in worldwide top 10, I think Google is there, Facebook is there. So these two companies and Microsoft, three companies. Okay, so we're using R. Now why R? So actually everything. So questioning. So why people they're switching to R? Okay, so first of all, the major thing I'm indicating here, see the slide, is a free installation. Installation is a free, so it is open source. So no, nothing is there, no money, no cost. Okay, so other in SPSS, so last 6 months back, so I'm asking SPSS package to my friend. So they talk about they given the quotations around 2 lakhs per 5 models only in SPSS. But so our program is a free installation and vast community. So if you have anything problem and if anything the discussions to go and so gives the vast community to maintain and searching the community and give your problem, and definitely so you will get solutions from community. So asking some suggestions also. So the vast community. And then implementation of high-end statistical methods, high-end statistical method. So it is nothing but so R can maintain the large number of data, millions number of data, so they can maintain, and sophisticated statistical are available. So that's why the people so more interested to R. To integrate with other languages, so integrate other languages, it is nothing but so I'm having data, so different types of data. So it is nothing but I'm having some Word document data, I'm having some SPSS data, I'm having some Sista data, kind of thing. So integrate with all other languages also. So data analytics and predictive analytics. So these are the two very important. So once having data, so you go under data analytics. Data analytics is nothing but we are going to deep learning. So some noise is there. Subramaniam. 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 So some noise is there. Okay, so data analysis plays an important role for kind of in research or any project to analytics and so give some solutions and conclusions. In part of predictive analytics, so predictive analytics is nothing but to building a models. Models is the mathematical models or statistical models are combined with both mathematical and statistical models to predict something. So in a future scenario. So for example, I'm having so first 50 data points or 100 data points for rainfall. So can I estimate, can I forecast what is the tomorrow, the forecast, the tomorrow rainfall? So day after tomorrow rainfall. So 95% or 99% confidence things. That is called predictive analytics. And high-end graphics are there, sophisticated graphics, that is a dendrograph. That is kind of some spatial the graphs are available. Okay, applications and advancement, and platform is independent and latest cutting edge technology. So moreover, so I'm giving here only 5 that is a bullet point, as well as the people are very interesting, the global average salary. So in right side, that is a $68,169 per annum It is closely, it is average salary I'm talking about. Who are completed any degree, B.Tech, B.Sc, whatever may be. Okay, so has vast experience, as a certified or courses or learning, or so 2 years experience I'm talking about. Okay, so it is a minimum 2 lakhs or 1 lakh per month salary. So in India, so last 6 months back, searching what is the payoff for R. So that is 3.5 so per month. Okay, so 3,50,000 per month salary. So that's why the people are it is crazy to learn R and shifting to R. Okay, so here installing R. So it is installing or download at the latest version of R for Windows from Crane. So R it is available for so Windows as well as so Mac computers and Apple. Okay, so the different the platforms there. Okay, so here this is a Windows given. This I'm giving some the links are there. Crane or project Windows base is there, and these three. Okay, so just to you can go and download from Crane and select a download site, download the base package at a minimum, download contributed package and needed. Okay, so just for example, so I'm just a minute. Okay, so just I'm taking with the help of Google. Okay, so here type so that is R. Okay, so simply you can download it. Okay, so downloaded R. Okay, so showing download R. So download R 4.0.3. It is the latest version. Windows the R project for statistical. Okay, so just click on this one. Okay, so download R403 for Windows. This 85 megabytes, 32 4 by 64 bit. So you can download it here. Okay. So these are the given some of the package is there R403. Okay, so otherwise, so you can take with the help of, for example, R Studio. Okay, so just download. Okay, so R Studio, you can click on this one, IDE, downloaded the R Studio IDE, R Studio, just to click on this one. Okay, so you can download both R and R software. So this is R Studio, I'm talking about R Studio for IDE, choose your session. So down the, so your cursor, so here R Studio Desktop 1.3.1093. So first install R Studio requires 3.0.1 and download R Studio Desktop. Okay, so downloaded R Studio for Windows. So not only, so you, so somebody, some people, so download only install R, that's it. Okay, so R Studio, it is very helpful for IDE to writing program something. So you can download first one and second one. Okay, R Studio Desktop. So here given, so their price also, don't go for buy download here. So there is a free R Studio Desktop free. So giving integrated tools for R, it is available. That is a tick mark is there, and AGPL R Studio Desktop, it is free. So you can download this one. Okay, so this is R Studio. Just I close this one, and again we are going to slides. Okay, so here workspace space. Once I download everything, so our session, all objectives are stored in a temporary and a working memory. And so my list of objectives. So this is slide. So everybody the same picture, same pitch. Pushpa, Subramaniam.
Yes, sir. Yes, sir.
Okay, so this is PPT. So here given some of the function and R, that is LS brackets and remove objects. This is list objectives. So this is remove objectives to save the file. Okay, so directly I'm going to take R. Okay, so just see here. So this is for R Studio. This is for R Studio, and this is for the source of data. This is for console. So we have only 4 things here. So this is for window for R Studio. So the importantly the main the 4 windows are here in R Studio available. So first one is a code editor. This is for code editor window. This is for R console. This is for workspace history and plots and files. These are the plots and files. So these are the 4 important windows: code editor, R console, workspace, and plots and files. So these are very, very important. So if you want to maintain the files and plots, packages, help viewer are all are available. So in this particular the small window. Same thing here, workspace and history is there. So environment, history, connections and tutorials. If you want to, you go and click there. And this is for code editor. So if you have data and sheets kind of thing. So this is for console. So you can write some coding also. So here. So these are the 4. And if you want to help here, so getting help. So for example, here I want to go for a T test. Okay, so T dot test. This is a question mark T dot test. Otherwise, you can type only help within brackets T dot test. So definitely come to some essays or some information about it, particularly statistically T test. So this is a getting help. If you want to help, so you can type something here. So this is a blue letter. So in my PPT, so I'm giving blue letters. So that is so you just you copy and paste and R Studio. Now, so the thing is that so how we import my data. So for example, I'm having data, some SQL data is there, some Excel data is there, some CSV file is there, some Systa data. So different files are there. So how I import a data from Excel to R and Systa to R, SPSS to R, or Word document to R, Notepad to R. So here the text tab. So if you have data, text tab data, so you can write, so my data, this is for your file name or any variable name. So it is, so give your name and less than hyphen read dot delim. So file, choose your particular data. Otherwise, if CSV file data, so you can use this one external file data and create objectives to then enter the data. So this is for concatenate and prompted data entry. So these are the giving some of the examples. So here once I'm using, this is a price is a variable name or it is a parameter name, less than hyphen read CSV file. So this is for C, so semicolon slash users Dell PC desktop. So these are that is a path. I'm giving some path kind of thing, so you can use. Okay, so now comes to so your data. For example, I'm going to for SPSS. Okay, so this is SPSS data folder. Now comes to here. This is for file is there. Once I click on file, so this is the same thing similar to our Word document. So that is a Microsoft Office, new file, new object to open file. So here some of the given options are there. Save as is there. Same thing is similar to our Word document. So this is editor, code, view, plots, everything is there. Okay. So who are new users? I think so. New users already somebody so vast experience in R. Okay, so gives some of the simple things. So for example, this is a console. This is a console box, and just I'm giving 2 plus 2. Just enter. That is 4. So 4 is there. Okay, so that is a 2 minus 2. So this is 0 is there, and 10 12 multiplied by 10. This is a multiplication is there. A small the operating, that is a mathematical operatings are there. You can start with very basic and simple things. Okay, so for example, can I take this one log? Okay, so once I typed log, so here so many things are there. Log is there, log 10 is there, log 1p is there, log 2, log b. So already this one, the functions are there. Log computers, logarithmic things are is available. So these are the, and also descriptions also is mentioned here. So just I deleted this one. So once again I typed log. Already here log is there. Just go and click on first one, log. So what is the log here? So can I enter here log, only brackets are this I can enter. This is error message is came. So why the argument x is missing with no default? So it means log give your value. So that's simply I'm going to up arrow mark, just simply up arrow mark. Okay, so up arrow mark, it is indicating it is a previous. So I have given the functions. So that is automated highlighted. That is a log brackets are there. So instead of this one, once again I typed log. Okay, so within brackets log 25. I want to need calculate the value log 25. So you can log 25. So same thing. So you can prepare and you can use the so many things here. Okay, so this is for starting. So once again, so I'm going to take with the help of this one. So here I mentioned, see here. So these are the basic arithmetic operations. So when starting, basic arithmetic functions also is there. That is a log 2, this is absolute value, and this is a square root value. So in this picture, so I'm going to copy. So simply I'm going to take this one. For example, this way, there is a square root of 4. Just you can copy here up to here, and so you can enter. So your R Studio, copy and paste. That is a SQRT4. Just you can enter. That is 2. And also you can give the SQRT starting with the brackets, and so 458. So you can enter. Okay, so it is very easy to understand, and easy to write some programs also. So here given. For example, these are the vectors. For example, friends age. So this is my heading, and it is a variable name. Call is a variable name. Friends age, and C stands for there is a concatenate. So my friend's age is followed by 27 years. One of the friend, the second friend 28, 26, 29, and my age is 24. Okay, so this is okay. So this is, you can give the numbers also. Now I want to know that is a mean. What is the average friend's age? Friends average. So for example, so what is the average value? Average value is very simple. Sum of all the values divided by number of values. So here 5 friends data, that is age is data divided by 5. So mean friends age. So that is this is a maximum age. So can I type same thing, or just one? We are going to with the help of this one. Just I copied here everything. Otherwise, so first time, so I'm going to take with the help of R Studio. So this is R Studio. So everybody same page. So this is our studio console editor. Now I'm going to take, there is a friends. Okay. So this is a friend. So I'm giving one variable. So less than hyphen start with C. There is a concatenate brackets open. Same thing, 27 years group, 28 years group, 32 years group, 28 years group, 24 years group. Okay, so I'm giving the numbers, the age in years 27, comma 28, comma 32, comma 28, comma 24. Close the brackets and simply you can enter. It is a no error, nothing is there. Error is a nothing but highlighted some different color, that is a red mark. So here no error is there. Now this is a front CS. So what I did here, same value FRIE end. Okay, just I typed here, please enter. It means the friend I'm setting, I'm given a variable name. So that variable has 27, 28, 32, 28, 34. Now I'm calculating mean. You just typed MEAN already highlighted. See here. So it is a default, the functions are there. It is a one type of, it is a beautiful. Once I'm going to MEA, so highlight.
Sir?
Hello?
Okay, sir.
Okay, so now here, so I typed only mean value, that is MEAN. So mean is there within brackets. So what is the variable defined here? So my variable is FRIEND. Okay, so already highlighted here, already given the name. So you can type and enter the value. So that is a mean value 27.8.
Sir, your screen is not visible, sir.
Okay, okay, just a minute. Now it's okay.
Okay, sir. Okay.
Okay, so now, so this is for the value. I'm going to calculate the average value of my friends is 27, 28, 30, 28. So this is a mean value. So same thing here. Uh, Once again, we go for already in my PPT. Okay. So these are the friends is everything is there. This is called as some vectors. Now, so when I'm going to plot any graphical representation, so just here I'm giving only one example. So I don't have much time to explain everything. And so I'm going to, with the help of R, just to copy and paste. So what, so does it mean here? So plot sine sequence 0 to 2 multiplied by the pi value. So length equals to 100. So why here three brackets are there? The first open bracket is there, second open bracket and third open bracket. So that's why, so three open brackets. So it is followed by three closed brackets. So they at the end of. So it's a plot. So I plotted something here. So just we are going to take enter. See it right side here. Right side. So one graphical representation is there. So these are the called some the picture, that is a plots and files. These are the one editor. Files and plots are there. So these are the plot is there. So if you want to zoom, so you can zoom it here. This is for a zoom. So this is a zoom, so graphical zoom. These are the index, so 0 to 100 given the numbers. So there is a -1 to 1. So there is a function sine sequence 0, 2 multiplied by pi length equals to 100. So giving a small program, we can practice it. Okay, so these are the plot something, and these are the some matrices are there. Matrix 1 is to 6, that is a 1, 2, 3, 4, 5, 6 values, 3 rows and 2 columns. Just you can type here, for example. So matrix, so you can take with the help of This one, just copy and paste here. Enter. See it here. Matrix 1:2, that is 3,2. So I'm going to prepare one matrix. The numbers are 6 numbers, 1, 2, 3, 4, 5, 6, and 3 rows, 2 columns. You can just enter a small the function, a small function. So take matrix. You can type matrix, brackets open, 1:6, 3,2. That is a 1, 2, 3, 4, 5, 6. So here the different modes are available. Okay, so matrix data equals to 5 is a constant data. NR stands for number of rows. NC stands for a number of columns. Number of rows equals to 2, number of columns equals to 2. That is 5, 5, 5, 5. So we build some matrix things are there. Okay, so it is given some values, and so we are going to take this one data frame. Data frame is nothing but so I'm creating here. So I'm creating here L one variable. So that is a concatenate. So the values are 1:10, and K equals to one variable. So concatenate. So the values are given data frame. So together these two variables in a time data frame. So you can type data dot frame L comma K. L is one variable. So L is a one variable name, and K is also one variable name. So summary is new. Okay, so these are the example. So just here, what I did here, just I'm going to copy this one data completely up to here. Okay, so up to here. So copy, and you can take our studio with help of, you can type and enter. See that here. This is for console. L is a standard. So I'm creating one variable name, that is K, that is L. So you can take any value. So any name here L. This is given 1 to 10 numbers. K is numbers. It is nothing but I'm having two columns data. So L having 1 to 10 numbers, and K having some numbers are there. Now here new, so data frame 1 comma L comma K. L comma K means L1 variable, K is one variable. Summary new variable. Summary, it is nothing but simply the descriptive statistics. What is the minimum value, maximum value? So first quartile, second quartile, third quartile. So so these are the some of the values are available here. Okay. Now so here I'm going to take median value, median. So here already given some values, that is K. Okay, simply I typed K here, median K. So this is a median K is there. Now I want to need mode within brackets K. Just you can enter mode value. There is no mode value here. So repeated all the values only one time. So so that is a mode equals to numeric is there. And what is the LS? You can remove musty. So anything you can use in the descriptive statistics. So also here I mentioned some of the formulas. So in my PPT. So definitely I sent to you later on. So here given one of the example is there, body mass index data frame. So these are I'm giving example. So for your understanding. Okay. So here I'm going to take some graphical representations. So that is a simple bar plot. The histogram is there, line graph is there. Okay, so here I'm giving variable name that is given values, that is a concatenate 7, 12, 28, 4, 58. Now the function is or bar plot where. This is a where is there, my variable name. So here a variable name, this is variable name. This is a bar plot variable, color is red. So now, so what I did here, in my so values, just I copied this one. Okay, just I copied what I have. Just I'm going to copy in our studio and enter the data. See here, right side some graphical representations are there. It means come to what is my program, where program is very simple. So where is my variable name? So these are the 7, 12, 28, 4, 58 my values. Now, so I'm going to prepare some bar plot. Just you can type bar plot. So given your variable name, where, that's it. Now here bar plot variable, already variable given, color is red. So you can change so your color also. Just copy these two and paste it. So instead of red, I'm going to take yellow. Yellow, just you can enter. This is yellow. So append yellow. So come with some yellow. This is called bar plot. The one object. It is very simple in the graphical representation. So the thing is that so the preparation data is very, very important. How many rows data, how many columns data. Already you have some Excel data, no problem, nothing is there. Just you go and import Excel data and write a program. Okay, so already programs are available. Already programs are available. Okay, in packages and different. Just you copy it and you can change so your variable names. That's it. So this is not a rocket science theory. Okay, it is very easy to understand and prepare. And also what I did here, this is a line graph is there, histogram is there. Okay, so these are the given some of the problems. See here in this slide, line graph. Line graph, I mentioned one of the variable that is li. I'm given my own name li. So these are some values. Okay, so line, so time series ts li. That's it. It's a plot line. So what you people, so for I'm talking about who are new users or new learners, so just copy and paste so the line graph. This is called for pie chart. So I'm going to take this with help of some pie chart is there. Okay, just you copy here pie chart and just you go and take with help of R Studio. You can type here, I can enter. This is a pie chart. Okay, so if you want earlier, this is some arrow mark is there. That is a left side arrow mark is there. Previous plot. These are called previous plot. See here, this is called previous plot. These are the previous plot. So earlier, so this is I'm using neural network. Now this is a previous plot. Or otherwise, if you have zoom, this is a zoom is there. And if you want to copy and paste, export, the option is there. Save image, save PDF, copy to clipboard is there. Some export is there. Otherwise, this one clear the all plots. The icon is there. There is a brush icon. Clear all the plots. This is export. This is zoom, and this is a files. Everything is there. So once you dig on down and what is what, so you can learn about. So these are the given some of the example. See here, simple XY plot graph. This is for randomly generated numbers. So randomly generated normal distribution. This is a randomly generated distribution, that is a X and Y. X is a one variable name, Y is a one variable name, and plot X and Y. This is small simple graph. So just copy these three lines and so we are going to take the help of R Studio. Just copy and enter. That's it. Okay, so some error is came, that is a X in R norm, Y norm. Error in plot X and Y, could not find function plot. It means they required some packages. So some already I told, so 12,000 packages are available. So if you install packages, so one of the option is there. All of you observe here the packages, some icon is there. You can type packages here. Okay, so once you type packages, install one of the option is there. So these are the use library. So earlier I used to some libraries are there, some packages are there. Now if you want to install new thing, so install, you click on install packages. So a small window is came, packages separate. For example, I want to need that is a time series. So TS are time series. Okay, so time data, time delay, everything is there. And also T series is there, TS is there, T series is there. You click on time series, install dependencies. It is very, very important to install all dependency packages with related to time series data. So you click on install. Okay, so if does not work your R Studio, you can take with the help of install. So already you googled something. So you can plot x and y, x comma y. So does not work. So what is I want to need the plot any packages or any installing packages. Okay, so this kind of thing, and I'm going to take one data set. There is a multiple linear regression data set. So already it is a data set available at RStudio or Crane. So that is a data set name is motor trend car road test data. Motor trend car road test data, that is a MT cars. The data set name is called MTCARS, MT cars. So actually, so this data was extracted from 1974 Motor Trend US magazine and comprises experts everything. The variable names are given. These are the variable. So nothing but these are the columns data. MPG, so miles gallon, CYL, number of cylinders, DSP, displacement, gross horsepower. So these are the giving some data set, default data sets. So this data contains 32 observations, 11 variables. 32 observations is nothing but 32 rows and 11 variables. It is 11 columns data is available. These are the given data. So these kind of data, we are going to plot some violin plots, violin plots. These are different kind of plants in a, biological students in agriculture or genetic plant breeding. So in my agriculture, so they are using some violin plots. So it is a kind of some box plot diagrammatic representation. So it's required install packages. So VO plot. Okay. So once you installed everything, you go and check it library. So VO plot, and you can take some of the program is there. Already I told this one empty cars data. This is default data. So this is a variable name. That is MPG. This is a variable name. Everything is there. So first you understand. So what is a program? Everything. This is a title. I want to need the title. Okay, so first see here, so what I did here, this is only for one the graphical representation. I want to need, so here copy this install packages. I'm going to take with R. Okay, so type something. Okay, so error install packages, so web plot. So that's why I install here. So this are typed here VIO. So already, so VO plot is available. VIO PLOT plot is available. You can click on this one, install once again. So if works or not here, so it's working. So downloading something here, packages. Okay, so again I'm typed library. So that is called VO plot. So already VO plot is there. Okay, so just I typed this one, loading required packages, someone. Okay, so just I try something here. Again, I'm going to take this one. Okay, so I complete copy this one, this program. Okay, just I come to back here, my RStudio. Okay, see here. So this is looking good, I think. So violin plots for miles per gallon. Okay, so this kind of some box plot things to go for a normality checking. You people heard about there is a box and whisker plots. Okay, this is a 4 cylinders and 6 cylinders and 8 cylinders. Okay, so this comes to, so violin plots are there. So everything, and so you can change something, same programming. So you can change anything. So color is gold. Okay, so what I did here, once again the same program. So instead of gold, just I'm typed here red, red, red. Okay, so once again you enter the program. So there is a red is there. So do not write anything. So from the starting, so what I'm suggesting, so new users, students, as some of the faculties, so you can copy and paste the programs. You can change. So first you understand, so what is meant by, so what is given everything. You can change some of the value sum of things. So definitely, so you will be get. This is for Zoom. This is for export. Already I told. Comes to same thing. So this is a box plot is there. So I'm giving some of the problems for your understanding. This is fun. See here, this is a canal density plot. That is a defined some D density. These are the C brackets of 15, 46, 68. Plot D, there is a polygon. Just copy and you can paste here your R programming. So now tell me, these are the density of the part. So I think in the graphical representations in R, it is a sophisticated, advanced. It is a amazing graphical representations are available. So, but the thing is that so you people identify so which are the packages and which are the graphs are available. You can install with the help of the packages. So everything. Now time is 11. So can I take 15 minutes?
Okay, sir. Okay.
Okay, so can I take 15 minutes? So my friend Muniswamy waiting. So next presentation. So just so these are the, I'm giving some R functions. So see here in descriptive statistics, that is everybody knows about characteristics of the data. Once you identify characteristics of the data, so you can go for the further analysis, advanced analysis. Your data consistent or not, your data follows normality or not. So there is no the discrepancy. So in between points, variables, everything. So that's why. So every time, so once continuous data having some measurable data, definitely everybody go for descriptive statistics to know about the characteristics of the data. So characteristics of the data is very, very important. So both are so measure of central tendency, measure of dispersion. So here R functions are given. These are the yield. Yield is my the name, variable name. So these are my values. Yield 28 kgs, 45 kgs, 56 kgs. So these are the measurable and continuous data. If you want to average mean yield value, these are the yield. This is a yield is my name. Okay, you can type mean, median, mode, where this is variance, standard deviation, quantile, minimum value, maximum value, interquartile range, and summary. So summary, it gives only minimum, maximum, mean, median, first quartile and third quartile. That's it. So not for all those things. There is only one option is available, that is called summary yield. Yield is my name. So you can type or copy. So the same thing you can copy it to RStudio. Okay. So this is for normality test. So I'm giving one of the statistical stuff. Normality test can be used to perform Shapiro-Wilks test normality for one variable. It is very, very important for so next further analysis, forecasting, everything normality. So if data is a normal data, no problem. If abnormal data is nothing but having some outliers, some discrepancies is there. How you go for non-normality to normality. So this is a one test is a given. It is a simple test, that is a Shapiro test price. So simply, so what I did here, so I'm creating one data set, that is a price, and Shapiro dot test, so within brackets. Okay. So what else here? So what is the final conclusion? My probability value greater than or equals to 0.05, implying that the distribution of the data is not significantly different from normal distribution. In other words, we can assuming the normality. Otherwise, we go for the remedies also. So this is for correlation test. So simply what I did here in correlation. Okay, so in this one example, just I go by this one correlation, copy this one. Okay, paste here. So just to type, this is a Pearson product movement correlation. So what I did here, yield C, given some values are there, rainfall data. So correlation, it means having some pairs, that is a needed paid data. Paid data is nothing but yield 9 values, rainfall also 9 values. 10 values or 10 values also. So what is my intention? My intention is to calculate correlation. The simply only one R function is there, correlation test, COR dot test yield comma rainfall. Yield is one variable, rainfall is one variable. See how the results are came in this picture. Pearson product movement correlation, data yield and rainfall. My T value is there, T value is there, degrees of freedom is there, probability value is there. So everything is there, and also sample estimates also is there. That is confidence intervals, 95% confidence intervals is there. Sample estimates also is there. So these are the given some output data. Okay. So now, so same thing here. Simple linear regression. Simple linear regression having one dependent variable, one independent variable. So I'm not touching upon my big data. There is a number of rows, number of columns. Just I created a small things from the starting from the beginning. DE is a stands for a dependent variable. You can create your own variable and give your values. That is with starts for C. Okay, so these are the independent variable, one independent, one dependent variable. That's a simple linear regression. Though the function is very simple. So I'm creating this model. This is a name. You can create your own variable. The function is LM. Okay, so linear model LM dependent variable. This is called tilde. Tilde is a nothing but you can press control. That is that is last one border. Top of the corner, that is a left side top corner, one button is there. So that is called tilde. So these are the tilde value. Okay, so model LM. So LM, there is a dependent variable and independent variable. This is called model. What I did here, just copied this one and okay, you can paste here. Okay, you can paste here and you can see this one. Okay, so these are the correlation, everything is there. Okay, and here copy this one and you can use in a dependent variable, independent variable. So see here. So these are the coefficients. That is a linear regression model. So independent is there, everything is there. So can I take ANOVA, ANOVA? ANOVA is there. What is my variable name? That is a model. You can click on this one, enter. This is ANOVA table is K. Okay, this is a simple functions. So do not go for ANOVA. So all the formulas are there. There is a total sum of squares, so mean sum of squares, so everything is there. So do not go for the kind of the small one function is there, that is called LM, linear model, dependent variable, independent variable. So if you have so many independent variables, so what you people did here, the dependent variable tilde, independent variable 1 plus independent variable 2 plus 3 plus 1. So how many independent variables you can add, or so many independent variables? First, you can define your data set. Okay, so that is one kind of situations here. So here it is a inbuilt bed data. So correlation is there. Some of the given data. Okay, so these are the given some of the functions. So once you have time, what I'm suggesting, you can copy and this one. So the other useful functions are there. Coefficients, fit and confit, fit, level 5. So here is the descriptions also I'm given. If you want to predicted values, you can fitted fit. So what is a fit? So fit is nothing but your data. So these are the prepare your data. Okay, so prepare your data. Already empty cards is available. Use empty cards. These are the empty cards. Okay, data empty cards, summary empty cards. Okay, so install packages car. You can copy and paste library car and str empty cards, which gives a structure of the data. Everything. Check your data. Everything is blue color highlighted. Just you copy and paste there. Okay, so prepare your data. Everything is available here. And so these are the ANOVA. There is a covariance matrix and influence regression, everything. This is for a layout, your graphical representations. You can copy and paste here. Just to, I'm talking about what is the empty cars, it is available or not. Just I'm going to take this one. See here, just I typed empty cars. See, highlighted empty cars is there. This is the empty cars data. So nothing is there. Already it is a data set is available. Inbuilt data set is there. Empty cars. Already we talked about 11 parameters. There is 11 variables and 32 observations. These are the 32 observations. So can I go for summary? Summary. So please all of you. So summary. So what is this one? Empty cars. Empty cars already available. So these are the empty cars data. Okay, this is a cylinder data. This is a displacement. This is HP power, draft, everything is available. Only minimum, maximum, median, mean value, first quartile, third quartile. So, okay, so I have some kind of data. So the other option is there, that is called head. Head, that is empty cars. Empty cars data. So what you observed here? Only 1, 2, 3, 4, 5, 6. Only 6 variables available data. It means top first 6 data. It means these are the kind of this one. 21, 6, 160, 110 kind of. These are the top 6 data. Now head is okay. So what about tail data? That is called tail. So one of the option is called tail. Empty cars, you can type already data set names already highlighted. These are the tail data. So what is the tail data here? The last 6 values. So it means once if you're having the large set of data, I want to know, so what are the variable structure. Structure is nothing but, so what are the parameters, first 6, last 6 parameters, and what is the summary is there. Okay. So this one, a number of rows, number of columns, everything is there. So here I mentioned, so this way here, yield, so already here I mentioned this one, head, tails, number of columns, number of rows. So do you want to number of columns, number of rows kind of thing, and fit the data, that is a multiple linear regression, everything. Okay, so now multicollinearity problem, and then I'm going to one case study. So these are the outliers test are there. Okay, so just within 5 or 10 minutes, I finished my presentations. Okay. So, sir, Muniswamy sir. Muniswamy sir. Sir, 5 minutes తీసుకుంటా sir.
Okay, తీసుకోండి sir.
Okay. So just I finished this one last.
Okay, sir. Carry on.
Okay.
No problem.
Okay, thank you. And this is for advanced technique is there, neural network for R programming. Okay, so what is the applications actually? So we should know neural networks are more flexible and can be used by both regression and classification problems. So for sometimes I'm having data, I don't know, so how we classified the data. So classification is nothing but and male and female, or with similarities based on similarities, based on if their education qualifications. So actually I don't know, so the classification. So that type of situations, so you can use a neural network. So definitely you have some outputs are there. And also neural networks are good for the non-linear data set. Linear data set, it is okay. So for me, for forecasting, for estimating everything, but data having non-linear data, it is very difficult to the analyzing. So in this case, neural network is the best method. Okay. So neural networks can work with any number of inputs and layers, and neural networks have the numerical strength and can perform job in parallel. So actually where we use in a business scenario, in daily life, and in our current situation. So we go for pattern recognition. So most of people have been using neural networks for pattern recognition, face recognition or pattern recognition. Anomaly detections are there. time series predictions are there, natural language processing is there. So I'm having touch upon a few things, that is applications on neural networks only. It is one of the kind, it is plays key role for deep learning. So nowadays the people talking about data scientist people, deep learning people, supervised models, unsupervised models, machine learning, artificial intelligence, machine learning, deep learning, so kind of. It is so huge the role and the practices are available in a neural network. Okay, so just why, so last I'm having case study. It is very interesting case study, the simple case study. The following student scores are given below and estimate selected or not. So what does mean here? The historical data I'm having 6 students data conducting two subjects. For example, first student get 20 marks in score 1, in the score 2, subject 2 is 9. Particular person is selected, so based on their performance. Okay, see, I'm talking about historical data. I don't know, so what is the criteria for selection, the criteria for selected or not selected, I don't know. So this is for information, so keep in your mind for classification techniques. Okay, so second person 10 and 20 marks, so finally not selected. Third person 30-40 not selected. 20-50 not selected. 8 is this one, 80-50 80-50 also not selected. I don't know, the first subject score having 80 marks and second subject having 50 marks, so finally not selected. And this person, sixth student, 30 and 80 and selected. These are the historical information. But the thing is that so the new students came into this picture. So the 3 students having their scores 35, 78, 50, 45, 85 and 45. So how can I go for 3 students? Sir, can I selected or not? So can I admitted or not? So can I give admission or not in my college, in my whatever maybe? So these are my problem. Okay, these are my problem. So you understand, these are the historical data. I'm having 6 students data. I'm going to estimate last 3 students who are come new persons, joining new persons, and finally to estimate selected or not. So can you select or not? These are my problem. Now what I did here, so these are the data. This is actually that is a historical data. See here, creating data set. This is for understanding purpose. S1 already given here, S1. This is a PowerPoint presentation. S1 20, 10, 30, 20, 80, 80 up to 6 students. So I took only first 6 students data, 20, 10, 20, 20. This is already everybody knows about how to creation of data. Second one, S2, that is a score 2 data. Score 2 data, 90, 20, 40, 50, given all the data. Next, placed is nothing but admitted or not. Admitted or not, I'm giving scores. 1, 0, 0, 0, 0, 1. That is a 1 is selected, 0 is not selected. Simply I prepared data set. This is my information. I'm going to prepare S1, S2, placed. 3 variables only, creating data set. Once you created 3 data sets, next step going to single data set. All three data sets combined, one data set. So what is my name? My name is DF. That is I created a DF one name, data frame, S1, S2, placed. S1, S2, S3, same what we have given the variable names, same 3 names. And also the required library is install packages neural net. This is very, very important. Unless until does not work. They can't work. So install packages neural net. This is a packages already I told. So go to the files menu and you can select packages, install, you can type neural net. If you have internet connection, definitely you install your packages, required packages. And comes to neural networks. Neural networks, I'm giving you new variable name, that is a NN. Neural net, you can type neural net. Placed is nothing but This is my target variable. This is my response variable. This is my output variable placed tilde S1 plus S2 comma data df is a data hidden layers, that is 3 hidden layers. So this is for given some the logistic functions behind that, is a neural network, everything active dot fct logistic linear output. So you can type and copy and paste, that's it. Plot a neural network, plot NN value already given NN value. Same. So what I did here, what I prepared data set, what I've given data variables, everything they repeated. That's it. Now comes to create data set. This is over. First part is over up to plot NN. Now comes to S1, S2 test data. What is a S1? S1 I'm going to last 3 data points. This is I want to estimate 35, 50, 85. Same values. What is a S2? 78, 45, 45. This is 78, 45, 45. Test data. This is I'm giving new variable name test and data frame S1 and S2. That's it. This is called a prediction. This is called a prediction. What is my prediction here? Predict dollar net result. So probability value 0.5, 1, 0. This is 0. So this is the complete program, a simple program. So first you understand what is my results. My results came to in this picture, in this scenario. The seventh student, the probability value 0.9. 8th student, the probability value 0.000. 9th students will get the probability value 0.000. It means the probability value lies to 0 to 1. So we are assuming 1 is selected, 0 is not selected. That's why what I did here, finally, what I conclude 0.9, it is close to 0. So this person is selected. Selected is nothing but 7th person is selected. So they getting marks 35 and 78 selected. Second person 50, 45 not selected. 9th student 85, 45 not selected. So this is I mentioned here question marks. This is question marks. It means probabilities are 1, 0, 0 selected, not selected, not selected. So finally, so what I did, last 3 students, I selected only 1 student, 7th student. Remaining 8th student or 9th students, I'm not giving admission. So how it was, it is a completely neural network procedure. Neural network procedure. This is a small kind of data. I'm having some lakhs of data. Thousands of the data is available. Okay. I'm going to estimate, I'm going to predict, I'm going to give the admissions based on historical data, based on previous data, based on past data. So this is for what I'm trying this way. Same thing, what I did here, blue colors. Everything is blue colors are there. Okay. Just I copied everything, complete code, this one, complete code. Okay. So what I did here, this one, I'm going to take this one, complete code. Copy this one, copy and take with the help of RStudio, just copied here. See here, this one, everything is there. Okay. So these are the data points. So what is a neural network data? See, this is called neural network. Zoom. So these are neural network. So what I figured out here, S1 that is score 1, subject 1, score 2 or subject 2. So these are the values, these are the hidden layers, these are the hidden layers. So finally, what is my output? This is my output. So that is placed or not. This is a very point. What is the error? Error is very less, 0.0000869 steps or 101 steps. Automatically, so it runs with the help of neural network. Okay. So finally, so they will get some outputs are there. My outputs are 0000 like that. So this is having some outputs are there. Okay. So now comes to so these are the neural network programs, advanced technique for deep learning or machine learning or artificial intelligence. We're talking about so who are background in mathematics, computer science. So the people very well know about neural networks, how it works, everything. This is a small kind of data. Okay, so I'm giving some output pictures here also. Now we are going to see here, it is a very good graphical representation. So if you're having some sophisticated the packages, so there is a ggplot is available, some neural network, some packages are available. So see it here. So in this only one picture, so one representation, so many graphs are available. This is called some iris data is there. Okay, this is a car mileage data. So giving some graphical representation. So these are the, so I'm thinking these are the correlation, these are the gear to gear. So that is AM adapt, there is a empty cars data, everything. Here the bar diagrams are line diagrams. So this is for some kind of eye and hair. There is a brown, black, they are segregated some data. So they are giving the Pearson residuals are available here. This is called sometimes dendrogram for segregations, classifications, similarities for your data. This is also some dendrogram, special dendrogram. It is a highly sophisticated and graphically representation data. So here I mentioned the few graphical representation. This is a cluster plot. So very beautiful for the cluster points. So how you clustering? So based on similarities. So these are the graphical representation forecasting trend values. So see here, this is a principal component analysis. So by using factor analysis here with help of prediction or data points, everything is available. See it here. This is one type of graphical representation. This is for estimating for forecasting the weather forecasting. Okay, so this is called neural network. Earlier I told neural network problem. So these are the response variable, the remaining all the independent variables, age, labor, kind of thing. So this is high dimensional graphical representation. Okay, so income, education, so there is a prestige. Okay, so different diagrams, diagrammatic and graphical representations available. So here I mentioned some of the textbooks that's called modern applied statistics with yes. Earlier it was yes. Okay, so now it was R programming. Earlier it was yes, more or similar to the same programming, and programming with data, a guide to the yes language. It is a good so books available at Google, so you can download it. Okay, so thank you for giving me this opportunity.
Meena madam.
So any questions, any queries, Pushpa? So meanwhile, so I don't know, so postings are given, some of the given participants are so any postings, any asking any questions, so let me know, so we clarify that one.
Okay, sir.
So and then hand over to next presenter, so my friend Muniswamy sir.
Okay, sir. Meena madam, please.
Okay. Okay. Okay.
Over to Meena madam.
Thank you very much for your elaborated, informative, enlightened speech, sir. We are very much happy with your in-depth presentation and motivated us to learn more and make us to enter a new growth phase. We believe that we can benefit immediately from the methods you suggested for statistics, academicians, and students. Once again, thank you very much, sir. Any questions from audience?
So I'm in chat box. So somebody, I think Gangaram, they're asking need justification of selection of a candidate basing on historical data. So definitely it is purely based on historical data. So we don't know. So they're performing. So they're given. So that is called some neural networks. Some hidden layers they're calculated. Hidden layers, some variance values they're calculated. So based on historical data, and choose they estimate the coming 3 students data. In same thing in a banking sector also. So we have so many users the applying the loans. So many people, so many employees, they're applying loans. Okay. So what they did, bank officers, they go and verify all the details, and finally, so they're giving loan sanctioned. But in historical data, some of the historical data are not paid. So who are getting loans are not paid properly. So some people getting loans paid properly. So they done based on some historical historical past data. So based on that information, we are going to new person applied. So we'll give or not, will sanction or not. So that is called one of the good statistical technique, that is in neural networks. So I think so we have that answer.
Oh, sir. Thank you, sir. Any more questions from audience side?
Hello?
Okay, sir. Thank you very much for your nice speech, sir. Now, introduction of resource person from B.Muniswamy by Dr. M. Pushpalata. Over to Pushpalata.
Thank you, Meena madam.
Okay.
Good morning to everyone. Professor B. Munaswamy is chaired as Professor and Chairman PG.BOS in the Department of Statistics, Andhra University, Visakhapatnam. He was crowned with excellent academic qualifications and has 13 years of teaching experience. His areas of specialization are stochastic models, econometrics, statistical inference, and biostatistics. He had 24 handful of publications for his credit. He participated in various seminars, conferences, workshops, and also acted as a resource person, enriching the audience with innovative methods. He successfully completed major research project entitled The Awareness of Health and Nutrition Among Adolescents. Excellency, he guided 5 doctoral theses which were awarded. His professionalism enabled him to be a member of various boards and departments where he served with commitment. He was a member in professional bodies sharing his statistical knowledge in changing scenarios. Out of his excellence, he was awarded with cash prize of rupees 1 lakh towards best performance in NAAC third cycle peer team visit in the Department of Statistics, Andhra University, Visakhapatnam. Sir, it is my immense pleasure to invite Professor Munaswamy as our resource person and enlighten our audience. Sir, please address the platform.
Okay, thank you, Pushpalata, for giving an opportunity to share my thoughts in this seminar. Thank you. And also thanks for the management and organizers for encouraging the students in statistics domains. So generally, the statistics is not a simple device for collecting numerical data, but as a means of developing sound techniques for their handling, analyzing, and drawing human activity, social as well as physical, like biology, commerce, education, planning, business, management, information technology, and so on. So what not in all the fields our statistical applications are using. So it is almost impossible to find a single department of human activity where statistics cannot be applied. So statistics is widely used in many industries. So in industries, like you see, control charts are widely used to maintain a certain quality level. Okay, now our senior Umar Nafeez sir also explained a neural network technology. So nowadays in the business intelligence, neural networks, artificial intelligence, so in all the interdisciplinary research those who are doing, but if you want to publish any paper or journals or articles or project works or statistical applications are using, right? Suppose in production engineering, to find whether the product is conforming to specifications or not. So statistical tools, namely inspection plans, control charts, etc. So are of extreme importance. So in inspection plans, we have to resort to make some kind of sampling, a very important aspect of statistics. Now I'm going to discuss testing of hypothesis statistical applications. So it is mainly sampling tests I'm going to deal. So in inspection plans, we have to resort to make a very important aspects of statistics. So for example, you see in the analysis of variance is one of the statistical tools developed by Professor R.A. Fisher, plays a prominent role in agricultural experiments. So in test of significance based on small samples. So it can be shown that statistics is adequate to test the significance difference between two sample means. So in analysis of variance, we are concerned with the testing of equality of several population means, not only a single. Okay, so and also the statistics is indispensable in planning. Suppose in the case of government sectors, government to take a policy decisions. So in the modern world, which can be termed as the world of planning. So almost all organizations in government are seeking the help of planning for efficient working, for the formulation of policy decisions and executions of the same. So in order to achieve these goals, the statistical data relating to production, consumption, demand, supply, prices, investments, income, expenditure, and so on. So, and various advanced statistical techniques for processing, analyzing, and interpreting such complex data are of importance. Okay. So, in India statistics plays an important role in planning, commissioning, both at the central and state government levels. At present, in the pandemic situation, COVID also, daily we are receiving data from the government and also estimating. Okay, but each and every individual's count is not possible. Okay, if it is possible, it takes time and budget, but based on the sampling techniques, we can estimate as a whole population characteristics. So this is just a brief my scope of statistics. Now I'm sharing my slides. Yeah. Right. Right. Is it visible? My share slide is shared.
Yes, sir. It is
Okay.
visible.
Yeah. So I will. So I will explain. So mainly my concept is testing of hypothesis. So generally, why we test hypothesis? General hypothesis means statistical statements about the population. Okay, let us see. So here, generally we are giving statements. In the hypothesis testing, mainly the statistics classifies two classifications. One is descriptive statistics and the another one is inferential statistics. So in the descriptive statistics, right, in the first lecture, Umar sir explained about descriptive statistics, computing measures of central tendency and dispersion measures. Okay, but in this descriptive statistics, measures of shapes as well as constructing one-way tables. So in the case of inferential statistics, data analysis aimed at testing specific hypothesis is usually called inferential statistics. Again, inferential statistics classified two. One is estimation and the second one is testing. Okay, theory of estimation and testing of hypothesis. Now I am concentrating on testing of hypothesis. So hypothesis means statistical statement about the population. Generally, based on the sample characteristic, we are estimating the population characteristic. Okay, so here characteristic in the sense, for example, you see heartbeat pulse rate. Okay, generally the entire universe, a common healthy man, heartbeat pulse rate per minute is 72. Okay, suppose I want to test whether the heartbeat pulse rate is 72 or not, but it is not possible to test the entire globe population heartbeat pulse rate. Just go to the field and collect sample observations from the population like this. So this is a few sample observations I gathered. So these sample characteristic is equal to the population characteristic. Suppose we want to test it. So we can formulate the hypothesis. That hypothesis is there is no significant difference between sample characteristic and population characteristic. So this is the hypothesis we are framing. But from the population we are drawing few observations. The technique is generally we are using random sampling technique. Okay, so my statement is here. I believe the population mean score is 20. So this is one statement. When the statement is you are accepting or rejecting. Okay, now you see. So reject hypothesis when it is not close to your average score. Okay, so this is, but after getting generally the statistics people are doing based on a t-test, okay, t calculated value is less than t tabulated value, we accept our null hypothesis. Otherwise, we reject our null hypothesis. Okay, but that null and alternative hypothesis are, so mainly our main goal is make statements regarding unknown population parameter values based on sample data. So here sometimes characteristics, population characteristics may known or population characteristics is unknown. Okay, if known, we have some other applications, unknown, other statistical applications are there. But null hypothesis means, okay, null means it is empty or nothing. So as a null hypothesis is usually one that says that there is no difference between two different events. Okay, for example, heartbeat pulse rate per minute, males and females are both are equal, means no difference. So that is denoted as H0 mu1 equal to mu2. So this is just a theoretical is there, but I will focus more on or how we analyze single sample t-test, two sample t-test, paid sample, ANOVA, chi-square, f-test, right? If time permits, I will explain factor analysis, multivariate analysis technique. Okay, so again, when coming to the alternative hypothesis, statement contradictory to the null hypothesis, we always contain an equality. Okay, but this is mu1 is not equal to mu2 means again two cases arises. One is greater than, another one is less than. Right, now coming to the significance test, t-test, why we test. Okay, so in our day-to-day life, whether knowingly or unknowingly, we are applying sampling techniques. Okay, but that sampling techniques characteristics here we are testing. For example, single sample t-test means if you know the population characteristics, then you can test whether based on the sample characteristic, the population characteristics is same or not. Okay, so if the sample size is small, then we use t test. We know that if less than 30 the sample size, we go small sample tests. So greater than 30, as we are all know that, right, z test we are using large sample tests, but it can be used to determine if two sets of data means are significantly different from each other. Okay, let us discuss one by one. First, we see one sample t-test. As we know that the formula sample mean minus population mean by sample variance divided by square root of sample observations. So this is one sample t-test. This is two sample t-test. But here, these two samples are drawn from the same normal population. Okay, but this is a paid sample t-test. So this is before and after test. Okay, so these three tests are used to test means, sample means. Right, now let us see. I will show one example just to go through that. A fertilizer mixing machine is set to give 12 kg of nitrate for every quintal bag of fertilizer. So in a 100 kg fertilizer bag, a machine supposed to mix 12 kgs of nitrate. Okay, but take 10 100 kg bags are examined, the percentage of nitrate are as follows. Okay, you see in one bag 11 kgs, second bag 14, 13, 12, 13, 13, 13, 14, 11, 12. So what we are going to test here, is there reason to believe that the machine is defective? Okay, suppose you are testing here, the machine is defective or not. So which test we are going to apply? Suppose to mix, but we know the population characteristic. Population characteristic is here, mu is 12. Okay, supposed to mix 12. But observed in 10 bags, the sample we collected, but it's mixing different sizes. Okay, but which test we have to perform? So already population characteristic known, based on the sample characteristics we can estimate, or we can test whether the machine is defective or not. So we can fix the hypothesis, the null hypothesis. There is no significant difference between sample mean and the population mean. Same in the case of you see petrol filling stations. Suppose you take, you go to the 10 different petrol bunks, take 1 liter bottle, you fill the petrol for 1000 ml, you test all the petrol bunks filling 1000 ml or not. Here the 1000 ml is a population characteristics, but you are gathering the petrol in the bottles, 10 bottles is a sample, whether the mission fills exactly 100 ml or not, whether mission false or operating false. Okay, for this kind of data, right, we apply one sample t test. So this is a single sample t test. Okay, but these generally our statistics students using these formulae. Here you substitute sample mean minus population mean divided by sample variance divided by square root of sample observations. But always keep it in your mind, sample size plays an important role. So your answer may reflect sizes to sizes. Always sample size is increasing, sample variance is decreasing. Okay, substitute here in this formula. But nowadays we have a wonderful statistical packages, need not to memorize dozens of mathematical statistical formulas, but just how to enter the data in or readable format, and you have to memorize some key statistical keywords. That keywords also daily we are using in uh, statistical tools and techniques. But in the traditional method, how we test, generally we are testing either chi-square value or t value or whatever it is. Generally we are using tabular forms. For example, t calculated value is less than t tabulated value, we accept our null hypothesis, otherwise we reject it. But now we are using either a significant test based on the probability value. Okay, that means what? The chance of rejecting the null hypothesis by coincidence. Okay, so that means if we use a significance level of, just to observe 5%, and we test 1000 observations, so we expect 50 observations to be significant by chance. Okay, so now this is, sir, at every 1000 sample observations, but it is 50 were significant. So generally by using of probability, that p value, so at present you observe any journals, a thesis submission or projects, they are giving either 1% level of significance, 5% level of significance, or not significant. But how to take a decision? Okay, let us see. First we enter, I will show the t test in SPSS. Just a moment. already we have a data sets here. So what is my problem? Whether the mission is defective or not. Okay, so this is nitrate. I created one variable. Okay, this is sample and data entry. So this is t dot test is a statistical tool for single sample test. Okay, but nitrate is a variable. Okay, so this is mean means population mean is 12, but already we have a sample mean. Okay, so just you copy and paste, Control C. Next, go to the R, right? Already we know that this is editor. Now I am pasting, Control V. Right. So this is the nitrate is a variable. I enter 10 values. Then you click this button, run button. Right, in this window, click this button. So nitrate data is ready. Okay. Now you can run the t dot test. Just it is a simple t test. But here you give variable name and here population mean. Okay, just you click run button. Right, you see. So it's given description is also, it is one sample t test. You see in the console window, right? Bottom window. Okay, data is nitrate data, t value 37. Generally, how we see in the degrees of freedom, 9 degrees of freedom, you see the tabulated value. Then if t value is less than tabulated value, we accept our null hypothesis, otherwise we reject it. But at present, we are using based on the p value. Here the p value is scientific. That means it is 0.0000. That means the mission is 0.00 means significant is there. It is a 1% level of significant. Though sample mean is not equal to the population mean. Okay, you see here also it given, yeah, this is alternative hypothesis, right? So this is sample mean is 12.6, but our population mean is 12. Okay, and also it given 95% confidence intervals. But how we interpret based on the p value. So always if the p values are greater than 0.05, okay, we accept your null hypothesis. If p values are less than 0.05, you reject your null hypothesis. Okay, so how we accept or reject based on the p value, just to observe in this slide, you see. Okay, this is 1% level of significance means your answer, the probability value. Whenever you run either to t test, f test, chi-square test, z test, or correlation, it gives probability value. Need not to keep statistical table values. Suppose t test, f test, chi-square test, we have to keep 3 separate test table values, but need not. Only observe p value. Just how to observe it, just to see. Okay, here actually one table is there, it's miss, right? Okay, something went wrong. Actually I have one tabular form how to interpret p values, later I will show. Okay, so this is how to interpret. Here it will display, just to see this tabular form. Yeah, but at the slide show it doesn't appear. Right now you see, suppose this is the p value, your answer, whether it is t test chi-square or whatever it is. So 0.04 means first to keep it here, the probability value. Is it less than? No. So 0.042 is greater than 0.01. So this condition is not satisfied. But you coming here, keep it here, 0.042 in this place. But it is less than 0.04. That's why it is 5% level of significant. Suppose you see in the second value, this is. Okay, so this is 0.001 means this condition you substitute here instead of p 0.001, it satisfied here itself. So it is 1% level of significant. But coming to this is not significant. But this is, you see, 5% level of significant. This value is 1% level of significant. Okay, so if rejection significance between the two means in the sense whether it is simply significant or highly significant, we can test it. So this is simply one sample t test. Okay, so that is right. Right, this is the data. So my p value is 0.000. That indicates that there is significant difference between sample mean and population mean. Okay, let us see one more data set I will create. But here in R, we taken simply just to observe in the editor window, created variable name. But suppose a random variable generation. Okay, based on the normal distribution, you generate a random variable. You see, I am generating one random variable. Okay, suppose heartbeat pulse rate. You see, Control C. Now you click OK button. You see. So this is what heartbeat is variable name. Okay. So this is R normal. So I am creating one random variable based on the random normal distribution. Okay. Sample. Okay. Creating our observations are 10. Okay. So mean parameters. Mean is 74. Our standard deviation is 4. Right. Then after placing the command, here run button is there. You click this button now. Okay, so it's created. Then you select heartbeat, then click run button. You see, just a highlighted heartbeat and I pressed run button. Now you see the data is generated. So this is what plus or mean plus or minus standard deviation. It produced a random variable. Okay, but these heartbeat percent per minute means whether the sample mean is equal to the population mean or not. We know that heartbeat percent per minute is a common healthy man is 72, but I want to test it. Okay, whether it beats or not. Generally, go to the field and gather the information. But this is the formula. You see, simple command in R t dot test my variable name, but compulsory we have to give population mean. So population mean is 72 here. Okay, just to see. So Control C. Now I'm pasting Control V here. Again you can run the data. Click it. Now you see this is one sample t test. So t value, degrees of freedom n minus 1. So 20 observations are there. It is 29. But p value just simply you observe it. Probability value. So p value is greater than 0.05. So it indicates that there is no significant difference between sample mean and population mean. Okay, so this is how we take. Okay, now you see sample mean is 72.514. Okay, So this is, then you can change here. For example, I am changing here 74 as 72, but here population mean I am changing 72 as 74. These two is interchange. If you change anything in the data set, compulsory we have to run again the data. So I am running, just to click this button. So you see in the console window, data is ready. Now click t-test. Right. Now you see the previous, the p-value is this. P-value is what? It is greater than 0.05. But now the p-value is what? 0.004. That means what? It is less than 0.01. It is less than 0.01. That means it is highly significant. So sample mean is not equal to the population mean. Okay, so here we created mean is 72, standard deviation is 4, but population mean is 74. Here the difference is there, okay, between the two means. But suppose we want to test, okay, so this is the data set. Just you highlight the heartbeat variable name, click run button. So this is the 10 variable 30 observations. Okay, so here heartbeat pulse rate, there is a significant difference between sample mean and population mean. But in the case of whereas nitrate data set, there is no difference. So mission is not defective. Okay, so this is how we perform one-way analysis of variance. But coming to the two-way analysis of variance, just to see. Right, just observe the data. I am showing only case studies, data sets, just to see. Two types of drugs were used on 5 and 7 patients for reducing their weight. Drug A was imported. So we imported from other countries, and drug B was native. So the decrease in weight after using the drugs for 6 months was as follows. So 6 months data. After 6 months they waited. But the thing is what? Drug A is imported from other countries. Drug B is our local native countries. So my question is what? Which drug I have to use? Either imported or native. Now you see our Modi ji also calling, please use Indian products. But generally, suppose if we are all Indians, okay, no doubt at all, but people are comparing product prices, qualities, whatnot, all the variables, comparison. Okay, generally price comparison. Okay, suppose our Indian product is 100 rupees, but foreign product is only 40 rupees. Generally, people are buying foreign products. Okay, but here my intention is how we test. So which drug I have to prefer, okay, for weight loss of these two brands. So my question is what? Is there a significant difference in the efficiency of two drugs? If not, which drug you prefer? Okay, so this data I will run. So two variables are here. Drug A is one variable, drug B another variable. So these two variables are independent. Normal distributed data. Okay, so this data I will run in SPSS, what is in R programming. Now you see, this is already I typed the data in Microsoft Word for time save. So this is drug A, drug B. Just to see, I am pasting. Control C. Okay. R. Okay. Already some comments are there. If you want to remove, just hold on the control key and press A button. It is select all. Control A. then delete, simple. Okay, but here in the console, click Control L, it clears your console window, Control L. Okay, now I am copying, Control C and Control V, pasted. So two data sets. Now just you select two data sets and then run. Okay, now data is ready, drug A and drug B. So here just to observe the formula, when compared to the single sample t test is also t dot test, there they given variable name and mu value is given, population mean. But here what, t dot test variable 1, variable 2, but here paired is false. So we are not going to use paired sample t test, just we are testing two sample t tests. Okay, just you run the button, click it. So now you see, so it gives t test, degrees of freedom, then probability value. Okay, so how we test the probability value? So this p value is, you see, it is greater than 0.05, means there is no difference between drug A and drug B. What is our null hypothesis? Mu1 equal to mu2. So the response of drug A mean equal to the response of drug B mean, we are assuming. But this says that your result, there is no significant difference between imported and local. Now you see, based on this data, now my conclusion is what? You are accepting your null hypothesis, means both response is same. So you are buying as imported or native. Okay, obviously we are buying native brand. Why? Means to support to our government. Why? Means our items we are purchasing. But this is how we compare numerically. But statistics believes what? Not name, fame and history. Statistics won't believe this. Statistics believes only numerical facts. So I have a two data sets. Okay, suppose I say I'm Indian, so I want to support a native. Can I say native brand is better than imported brand? No, I can't say theoretically. So that theoretical considerations we have to prove in a numerical way. So you gather the data, so apply. So now for these data sets, okay, so native and imported both performance is same, so we can support or we can buy native brand is enough. Okay, so this is the conclusion. But either SPSS or SAS or Benitab, whatever it is, the statistical package, it gives the output. But as a statistician, how to interpret it is very, very important. So this is t test. But as far as concerned, here you see t test. Okay, paid sample t test is false. And also here you observed confidence levels. So I am copying and I am moving. Just you see, Control V, then you run, right? Here is also. Okay, this is 1%, 0.99, or you can change 95. Okay, whatever you require, your confidence levels, just to change here. Okay, suppose 90 I am taking. Okay, again you can run the data set. Okay, right, now you see this is same, the answer is 0.4406, even though it is 90%. Right, so this is two sample t test. But as far as concerned, in the case of so, but you observe in the data set, it won't gives, you perform t test, but in the case of practicals, in the classroom, generally teachers are giving to perform or to carry out two sample t-tests for the following data, to perform one way ANOVA for the following data, to test a single sample t-test for the following data. But as a statistician, we have to identify tools and techniques for the case studies. This is a case. You have to identify which statistical tool shoots for this type of data. So this is a two sample t test. Now you see one more case study I will show. This is memory capacity of 10 students was tested before and after training. State whether the training was effective or not from the following data sets. So not only this, for example, you see daily we are watching in the watching TVs or in the news papers, weight loss. They are showing two images, before image and after image. But before image it is a fatty image, after image is slim image. Same thing in the hair plantations, before and after hair loss, how it is. Okay, so generally they are in the advertisement they are saying if you use my product, compulsory reduction of weight without any side effects. You see the advertisement in the TVs. Okay, so that's why here what I am going to test, suppose conduct one test to the students, 10 students, the marks were recorded. So you thought that you are not satisfied about these marks, so let me give training to the students. So we given training, either 1 week or 1 month, whatever maybe you given the training. But again you conducted one examination, you gather the data. So before training and after training, right? So what is here, the training should be effective in this situation. So now I am going to test, right? In future the training program may continue or not. So this kind of case study, how can we test in or just I am copying and pasting, Control C. Next coming to the or, right? So or Control A, just delete here in the console, Control L, right? Now it's cleared. Now I am copying. Okay, so this is before training is variable name, right? This is concatenate. So after training is another variable name, but this is simply a test, t dot test, that's it. So before training, after training, paired is true here, but previously what, here if you paired is false, you write it is treated as two sample t-test, independent sample t-test. If your paid it true means you are going to test before and after paid sample t-test. Just to click run button, you see that in the console window, the output is appears. You see, okay, you see the error. Paid is true. Just a moment. Just to observe all, if any spelling mistake is there, it won't accepts. Before training, after training, paired is true. Okay, so what is wrong here? Just a moment. First, I will run the data set. So I have not run the data set. That's why. So you run the data set, then go to run. Right. So in the previously what I did, mistake is I have not run the data set. So compulsory, we have to run starting of any tests, we have to run the data set. Right. Now you see. So I run the data set, then it appears. So this is what paid t test. So this is t value and this is p value. Again, you see probability value is greater than 0.005. That means there is no significant difference between before training and after training. That means what? So your policy decision is there is no coaching effect. If you give the coaching, you not give the coaching, the marks getting the students are same. Same weight loss. Before training and after training, weight loss is not reduced. So that policy decisions we take by observing these tests. This is simply we call it as paid sample t test. Okay. Now we go for f test. We know that this is in the case of t test. Generally, the test is used to test sample means, to test the sample means. But in the case of f test, to test the sample variances. Okay, we know that the simple. Okay, s1 square by s2 squares. So this is group 1 variance by group 2. But you see one example. Okay, two horses A and B were tested according to the time in seconds to run a particular track with the following results. So their running speed of horses is same or not? Is there any variation? So we go for F test. So the F test formulas in two sample variances just to see, just copy and paste. Right. So now I am copying. Right. Now you see this is, but here the variable value should be same. Here you see just processor A, processor B. So my question is here, suppose two processors in the computer, two different processors, speed if you want to test it. Okay, whether these two processor speeds are same or not, if there is any variation. So I am going to test this. So control C, same variable you have to give here, same variable name, control V, then control C, where the mistakes is to identify, control V. Okay, so this is the data set. Right. Now just copy, go to R. Okay, I am deleting, control V. First you run two data sets, run it. Oi, oi, oi. Just a moment. Right. So here you use bracket close. Right. Now you test, run again this. Okay. So F test is right. But the here what I taken as in the F test, two-sided. Then you can run F test. Again you click, run the F test. Now you see. So F test to compare two variances. But here is also always, whether it is a F test or T test or ANOVA, whatever it is, just to observe only the probability value. So here what? P value is greater than 0.05. That means there is no significant difference between processor A and the processor B. So any processor you can buy, the efficiency is same. So this is how we take a decision. So in the F test. Okay. Now coming to the uh, just these three tests I shown: one sample t-test, two sample t-test, and paid sample t-test. Now we go to the analysis of variance test. Okay, so analysis of variance test is what it is. ANOVA is just an extension of t-test. In the t-test, it is restricted to only two sample means. Suppose if you have three samples, how we test? Sample 1, sample 2, sample 1, sample 3, sample 2, sample 3. Only pairwise comparisons, right? So these pairwise comparisons, it leads to increase errors. So that's why we use significance test. Analysis of variance test is used to test two or more than two sample means, right? So simply just to observe. So three kinds of groups are there. I recorded heartbeat, pulse rate, control group in the sense without any exercise. This is gym group, those who are going to gym and recorded their heartbeats. This is yoga and recorded their heartbeats. Generally, which one is better? So anyone respond for this? I given three variables. Which one is better? Control without exercise, gym exercise, and yoga. Which one is better? Dear participants, just anybody respond. Hello. Okay, so I think so.
Sir,
You,
Controlling is better.
writing in chat box.
huh?
They are
Controlling.
writing.
Yes. Okay, okay. I think so. You are disabled. Hmm?
No,
Right.
chat box is enabled.
Chat box is enabled. Okay. Here I see the chat box. Okay.
Beside the share screen, sir.
Yeah, yeah. Okay. So generally, which one is better? Anyone can respond. So control group means without exercise. I recorded heartbeat, pulse rate, gym exercise, yoga. Which one is better generally? Hmm.
Controlling is better, sir.
Why, ma'am? Control means without exercise is better for heartbeat, pulse rate. Hmm? Hmm. So, but so many my lectures, I asked to the participants, say they given yoga is better. Why? In the sense nowadays yoga is popular, right? Even we are celebrating International Yoga Day. At that time, our Prime Minister also doing yoga. So now yoga is popular. Okay, but statistics won't believe a popularity, or statistics won't believe history, name, and fame. So it believes what? These three variables, keep it in. So you can run by applying statistical tools and techniques after getting the output. So based on that only, we have to say which group is better than another group. So here these three groups, now which one is better means we go for analysis of variant techniques. All the sample means are, these three sample means are equal or not. Generally our null hypothesis is mu1 equal to mu2 equal to mu3. Okay, so after getting the results, let us see. So this is a single sample t-test. Okay, what is that? Analysis of variance. Suppose you run this analysis of variance, you will get this is ANOVA table. In that ANOVA table, this is F calculated value and this is probability value. But need not to see tabulated values, just to observe this. This probability value is less than 0.05 or less than 0.01. So it is significant. So it says that this probability value is less than 0.01. So it is highly significant. That means what? You reject your null hypothesis. That means mu1 is not equal to mu2 is not equal to mu3. But which pair of two treatment means are differ? Okay. So at the time, Only analysis of variant test only won't give full report. So we can run post hoc tests, that is multiple comparison tests, that is LSD, least significance different test, two case tests, Duncan's range test. So many multiple comparison tests are there, so we can apply that multiple comparison tests. So that multiple comparison test, when we apply, if you reject your null hypothesis, then only we can apply Duncan multiple range test or least significant different test or two case test. So this is, but this is one data set, but I will show R in different data set. Now you see, so this is okay, ANOVA, but in the case of F test, this is only two sided. Suppose if you want to run one sided, this is left and right. So control C, just coming to the R, so control V, or here you paste it, control V, okay, just to click run button, okay. But why means here group A, group B is there, so we have to change variable name. So compulsory we have to give the same variable names whatever you declared, okay. Right, now you see click run button, okay. Now it's ready. Now you click F test, run it. Now this is okay, less than type. So okay, this is greater than, this is mu1 is less than mu2, this is mu1 is greater than mu2. So one sided and two sided tests also we can run by applying these simple steps, okay. Right, so this is F test. Now we go for analysis of variant test. This is ANOVA simple test. I taken three groups, group 1, group 2, group 3 data sets. Now first I am copying the data sets, control C. Now you see, control V, you can run at a time three data sets. Just you select and click run button. Now it's okay. Now you want to see the data, just to select group 1 and click the run button and see the console. So in the console the data is like this, okay. But as it is, this data it won't gives, so we can change this data combined groups, just to observe this, okay. Combined and staked groups. Suppose control C, I am copying and pasting the formulas. This is combined groups. You click run, then just to again you click combined groups, run it. So now you see, actually my data set how it is here, just to observe in the editor window, three separate variables. This is group 1, group 2, group 3 here. But now it is horizontal, but now it is vertical. I combined the data set, okay. Now staked groups also you can run it, okay. Now go for ANOVA and its summary. So control C, now control V. Now you run the ANOVA, okay. Again summary of analysis of variance, you click this button. Now you see, now ANOVA is ready. So this is group 1, group 2, group 3. Is there any significant difference between these three groups? So your now our null hypothesis is mu1 equal to mu2 equal to mu3. But how you take a decision, right? Based on the F value. This is, so this is ANOVA table. What is your F value? And also you see significant codes here they given. Okay, so if this p value is less than 0.05, difference is there, otherwise there is no difference. So it says that a probability value is greater than 0.05, so it is, there is no significant difference between the three means, three groups of this data. So this is simply one way analysis of variance, Okay. Now, coming to the two-way analysis of variance data. Okay. How can we run? Now you see, this is a two-way. I am reading data set. So the data is stored in my desktop. So Control C. So Excel file I am reading. Now you see Control V. Okay. Just you can run. Click this button. Okay. So when you run this command, the command is my data is a data set name. So this is read.csv file. The file I am choosing, but I have not given path. Now I have to select where it's stored. So this is the my data set I stored in Microsoft Excel. So just click open button. Now you see here, okay, data is appears, right? So now you click my data, run it. Now you see, so I stored data. Okay, so these three values belongs to group 1, these three values belongs to group 2, these three values belongs to group 3. That means what? Here I taken age and drug. In one way analysis means there is no age involvement. Okay, suppose here is there any significant difference between three types of drug? Whether it is difference or not, we tested. But age is also. These three are all. This is here you see in the drug 1, 2, 3 means three different types of drugs, but same age group. Group is 1, maybe 20 to 30 years. So 30 to 40 years again, three members are there. So it is three different drugs. Same 40 to 50 again 3. So this is the data set I am using. So now you run the model. Okay, again click the model. You see here you will get it sum of squares degrees of freedom, but you require a summary of the model. Just again you can run it. This is run. Okay, this is summary, but in the summary you need not to concentrate on all the values, just to observe only these values. So 0.337. So it is what? It is also P is greater than 0.05. Our answer is greater than 0.05. It indicates that there is no difference between, okay, age factor. Here you see this is the age factor. So there is no difference between the ages. But here what? This is p value for drug. Just to observe, this is the p value for drug is highly significant. Why means this is 0.000. It is a scientific value. 0.000. That means it is 1% level of significance. So between the drugs, difference is there, but between the ages there is no difference. That indicates what? So any age group the drug is suitable. There is no mean difference between the ages. It indicates. So this is how we take a policy decisions by using two-factor ANOVA. Same you can run a 3-factorial design, 3-factorial ANOVA. But you see only a simple 5 commands. Okay, the first command is to choose a file. Okay, where you stored in your appropriate sources. Just my data. Just you can run the analysis of variance for two-way ANOVA. Okay, so this is simply analysis of variance. Next we go for chi-square test. Right, just I will show. I'm not discussing much more theoretical. Okay, just I will explain applications. So chi-square test, generally it is used to test independence of attributes, but the data must be in the form of frequencies. The frequency data must have a precise numerical value and must be organized into categories or groups. That means categorical data. Generally, data are of four types: nominal, ordinal, interval, and ratio. Okay, for nominal type data, we will apply. But the expected frequencies in any one cell of the table must be greater than 5. We know that. Okay, but the total number of observations must be greater than 20 is better to do the analysis. But if you see the scale of both variables are nominal, we go for Pearson chi-square test. If the both variables are ordinal scale, Spearman's rho we apply. If interval or ratio scale type, we go for Pearson R. So this is based on the variable values. Okay. Now I will show one data set. Okay. This is the data set you observe. So sex is a variable, position is a variable, right? In the sex wise distribution have two categories, one is male, another one is female. In the position is also two categories, subordinate and manager. That means what? Variable values are names. Okay, this 14 is what? How many males in subordinate? 14 members. It is a frequency values, not any measurable. Okay, how many members of males managers? So for this kind of data, how interpret? So our hypothesis is what? Right, there is no association between sex and position. That means what? Is there any gender impact on the position? So mainly we are finding, is there any gender impact on the position or not? Okay, but hypothesis is what? There is no gender impact, our hypothesis. But after getting the result, okay, if you accept your null hypothesis, you are assuming that there is no gender impact. If you reject your null hypothesis, there is a gender impact is there. For that kind of data set, okay, how can we interpret it? Okay, right. So this is one class law. This is one data set I will run. Coming to the chi-square test, simply this is, you see, now we create a contingency table is a variable name table. So it is a matrix I given. Umar sir is also explained how to create a matrix. My matrix name is contingency table. So you see, I am running this. Control C. Right, I am pasting. Right. So Control V. Okay. Then run. Okay. Now contingency. But you see, column names are not there. First, just to observe the contingency table, just to click the run button. Now this is what? 1, 2, 1, 2. 2 rows, 2 columns. But there is no column and row headings. If you want to keep column and row headings, just to run this. So column CYL names, right? Male and female. Now you click run this button again. Okay. Let we see. So now you see, instead of here, instead of 1, 2, it is given as male and female. Same. Okay. Row names also. I given previously only column names. Now you see row name also. Okay. Now you paste. Now you see, this is the row name. Run it. Now just you click contingency table, run it. Now you see male, female, subordinate, manager. Okay, that means R is very powerful. Why? In the sense it is a client server. Clients, whatever their requirements, we can meet or we can design based on the client's requirements. But whereas in packages, for example, you see in the SPSS, already it is a select and click environment program. Already ready made is there, but it is a friendly user SPSS. But this is whatever the client requirements, we can meet it. Right. Now, suppose we view the contingency table, just you click, you run it. Okay. Just a moment. Yeah, you see. Now I run the table. Okay, here separate one window is appears. Okay, that is uh, a contingency table. Okay, this is a chi-square test I'm running. Now click here, then run it. Now you see in the console window. Okay, so this is chi-square value is 10.925, degrees of freedom is 1, that is r minus 1 into c minus 1. The p value is 0.000. That means what? If p value is less than 0.01, it is 1% level of difference is there. That means what? What is our conclusion? There is gender impact on the position. To owning a this for this table, there is gender impact on the position to hold. So this is how we interpret our results. Okay, this is simply tests, t test, chi-square, and analysis of variance tests. Right. Uh, మా పుష్పలత శ్రీనివాసులు
Sir,
అమ్మా మే స్టాప్ ద క్లాస్
so if you want, you can continue, sir, for 5 to 10 minutes.
So I have
Otherwise,
one
you
more
can.
application is there, that is factor analysis.
Okay, sir, you can
Just
continue, sir.
okay, just I will take 5 minutes.
Okay,
So
sir.
in the yeah, I will continue. So in previous I shown only sample tests, single sample, two sample, or two or more sample tests, chi-square and ANOVA. But as far as concerned in factor analysis, that means data reduction technique. Suppose a number of variables are there, but each variable analysis, it is very confusing, and also it is difficult to analyze number of dimensions. Okay, so we have to reduce the dimensions by applying factor analysis techniques. It is very simple. First, you see, I will show one case study how to formulate a problem. So this case study is just to observe. Suppose the researcher wants to determine the underlying benefits. That means what? Consumers seek from the purchase of a toothpaste. Okay, generally, what purpose we purchase toothpaste? Now you see the advertisement of toothpastes. Okay, Colgate, Pepsodent, Sensodyne, Patanjali, Ayush, so many different. But product to product, some specifications are there. So main thing is what the you see the respondents were asked to indicate their degree of agreement with the following statement using. Okay, why you use the why you buy a paste. So my question is this: first variable one, it is important to buy a toothpaste prevent cracks. I am posing this question to the respondent. The respondent may select any one of these options. Okay, so 7-point scale is there. So the respondent may select any one of these options. Okay, so the respondent may select any one of these options. Okay,
Sir, Munaswamy, sir.
I think, sir.
Sir?
Muniswamy sir left the meeting, ma'am. I think some technical issue.
Oh, okay, sir.
I'm thankful to you, sir, for accepting our invitation. Thank you very much, sir. For your informative presentation, which entitled us with new ideas and thoughts to be inculcated in practicing statistics in the present scenario. You are given a wonderful presentation how statistics plays an important role in the world by taking different case studies using t-test, f-test, chi-square test and ANOVA. We are delightful, sir. Thank you. Subramaniam, sir.
Ma'am. Ma'am, tell me, ma'am.
Subramaniam, sir.
Ma'am, tell me, ma'am.
Sir, Subramaniam,
Okay.
sir.
Okay, ma'am. Tell me, ma'am.
Sir, unmute Gangaram, sir.
Name, ma'am. Can you repeat the name?
T. Gangaram.
Okay, ma'am.
Good afternoon, participants.
Sir, good afternoon.
I am Dr. T. Gangaram, lecturer in statistics, PVK in Government College, Chittoor. It is very happy to participate in this webinar. Nowadays, at degree level, we are transforming our knowledge in theoretical aspect only. Just we are telling our syllabus, and recently we implemented Excel only in the syllabus. Nowadays, this Excel and SPSS they are paid packages. They are paid softwares we need to update them, and we must purchase them with a high cost. But recently, the open softwares came, and R software and Python softwares are very much useful. They are utilized very much to the practical purposes. We can solve almost all the problems by using R software and Python softwares. These type of webinars enlight faculty also, like our faculty need to know the recent changes and applications of statistical theory in practical aspect. Thank you for organizers organizing these type of seminars. And Professor Umar is my classmate and friend. He explained about R software job opportunities and getting started with R software, placements of R software. Nowadays, worldwide, around 40% of statistics users are using R software rather than SPSS, and SAS is also an expensive SAS software. Likewise, Professor Muniswamy garu, also my friend, he explained t-test, pair t-test, chi-square test, ANOVA, everything he explained. This webinar enlightened us very much. Thank you, organizers.
Thank you, Gangaram sir.
Welcome, madam.
Subramaniam sir.
Ma'am, tell me, ma'am.
Sir, unmute Padmaja ma'am.
Already unmuted, ma'am.
Good afternoon, everyone. First of all, I congratulate the Department of, am I audible, Pushpa?
Yes, ma'am.
Yeah. First of all, I congratulate the Department of Statistics, Mrs. Meena Kumari and Dr. Pushpalata and Dr. Srinivasulu for their immense effort in organizing this webinar. Really, I am so happy to hear more new things and innovative things in statistics and our software solutions. Actually, we are away from that field, but after listening to this webinar, we have recollected some of our research days where we have applied the statistics. And I personally thank Dr.Shaik Nafeez Umar, Assistant Professor, Department of Statistics. He has explained in depth about the R software applications and the use of it in the modern and the recent trends. Actually, we are totally unaware of these applications because we belong to a different subject. But I think, sir, you can try to aware such type of people like our through some workshop or some orientation, some other 1 or 2 day program with this R software application, so that there is a chance that we can use it in our regular research activities or some other study projects to the students. Really, I thank you very much, sir, for your innovative and enlightened information on this R software applications. And I also personally thank Professor B.Muniswamy, Professor and Chairman, Department of Statistics, Andhra University. And sir has given a detailed explanation of these t-test, that is one sample, 2 sample and paid t-test, and their applicability. Nowadays, without statistics, there is no scientific research, and we cannot get a scientific result without statistics. So most of the people nowadays, they are depending totally on the computer, and they are not unaware of these applications, even though they are using in their research process, but they are not at all aware of how to use it or how to get a conclusion. So by attending such type of webinars, definitely I hope that most of the faculty, research scholars, students, they will be definitely benefited. And I thank the Department of Statistics for giving such an informative webinar. Thank you very much.
Thank you, Padmaja madam. Subramaniam sir.
Ma'am.
Unmute Maheshwari, Government Degree College, Srikalahasti.
Ma'am, initial ma'am, there is three persons with that name.
P. Maheshwari, P.
No, ma'am, no person with that name.
Okay. Maheshwari madam is there, sir?
Yes, Maheshwari is there, ma'am.
Oh, okay, sir.
D. Maheshwari.
Okay, sir. Subramaniam, sir?
No, ma'am, no one with that name.
But here we are seeing some video is on. Okay, sir, unmute Munaya, sir.
Okay, okay.
Sir, మీరు phone
She is
చేస్తున్నారా?
with another name.
Sir, already Maheshwari madam is on video.
Okay, with another name. Okay, just unmuted. Continue, ma'am.
Pushpa, am I audible?
Ah, yes, Maheshwari. Okay.
Am I audible?
Yes, yes, Maheshwari.
Om Namo Venkateshaya. Good afternoon to all. Am I audible?
Yes, proceed, Maheshwari.
This is Dr. P. Maheshwari, lecturer in statistics, Government Degree College, Srikalahasti. At the outset, I am immensely delighted for being a part of such a wonderful learning session on recent developments in statistics and our software applications. The concepts delivered by Dr.Shaik, Nafeez, Umar sir and Professor B.Muniswamy sir are excellent, and the style of their presentation is highly commendable. Apart from the subject knowledge gained through this webinar, I learned how can I be an effective presenter in the classroom using R software, starting from installation of R software for free of cost, presentation of data, graphical representation of data, analysis of data, and interpretation of data by using learner-friendly or software. I really enjoyed the sessions, and I am sure that the concepts and the material presented will definitely be incorporated into my resources. I also appreciate the efforts put forth by the organizing committee for inviting such wonderful and highly knowledgeable speakers. It's indeed well organized and well managed. Thank you, and thank you one and all. Thank you, Pushpa.
Thank you, Maheshwari, for your wonderful feedback.
Thank you, thank you.
Subramaniam, sir? Subramaniam, sir?
Ma'am, tell me, ma'am.
Sir, unmute Munaya, PVKN Degree College.
Okay.
Good afternoon, all of you. I am Dr. Vimunaya from PVKN Government College. I thanks to the Department of Statistics, SPW College, provide such a wonderful webinar on focus of statistics. It is always indispensable because our eminent professors, two guys, Dr. Nafeez Umar sir and Dr. B.Muniswamy sir, explained all things about statistics with the help of R software. It is very helpful to the graduate and postgraduate students. Thank you. Thank you very much. Thank you.
Thank you, Munaya, sir. Subramaniam, sir? Unmute Sheikh Karim.
Already unmuted.
Okay, sir.
Madam, good afternoon to everybody. Hello, is it audible?
Yes, sir.
Good afternoon to everybody. First of all, I would like to congratulate the organizing members, especially Sri Padmavati Women's Degree College. Actually, I was also an alumni of S.C. Arts College, Tirupathi. Presently working in as Associate Professor, Sri Vidyaniketan Institute of Management. So congratulate. I am very thankful to the resource person Nafeez Umar sir and Muniswamy sir for throwing on lights, because R is now the emerging software. Even SPSS, I am familiar with SPSS and SAS also, but R is now the emerging software. Even in business, we can say that when without statistics, it is almost all branches. No branches can exist without statistics, especially in business to analyze data. So once again, I request Mangal to conduct this type of workshops, especially in area of R and others, for longer duration. It will be very helpful to the people. Thank you, ma'am.
Thank you, sir. Subramaniam, sir.
Ma'am, tell me, ma'am.
Unmute Murali, sir.
Murali, sir, please unmute yourself. Okay.
Hello. Is audible, all of you?
Okay, Murali.
Yes, sir.
Good morning, one and all. This is Dr. Murali from M.Sc University as an academic consultant, Department of Statistics. First of all, thanks to organizers of this seminar, beautifully organizing, and Department of Statistics, Padmavati Mahila University. And thanks to Pushpalata, she is my classmate. And one of the important thing today is those who are the resource persons, my teachers, Dr. Nafeez Umar sir and P.Muniswamy sir, a professor of Andhra University and Agriculture University, professor of Agriculture University, Nafeez Umar sir. Thank you, one and all. Good organizing by Department of Statistics once again. Srinivasal sir, and who are the back supporting for Pushpalata and Srinivasal sir, head of the Department of Statistics. Thank you, one and all.
Thank you, Murali.
Thank you.
Subramaniam, sir.
Ma'am, tell me, ma'am.
Sir, 1 minute over to Meena, ma'am.
Okay, ma'am.
I'm very happy. My heartful thanks to our resource persons, Dr.Shaik, Nafeez Umar Garu, and B.Muniswamy for delivering a nice speech on webinar topic. Once again, I thankful very much, sir. Thank you.
Over to Pushpa.
Over to Pushpa. Vote of thanks, over to Pushpa.
Screen roller, sir. Subramaniam, sir.
Ma'am, tell me, ma'am.
So I'm presenting vote of thanks.
Okay, okay, ma'am. Continue. Ma'am, continue, ma'am.
Oh, okay, sir. So I express my happiness towards the participants who has registered for this webinar and great regard to the resource persons Dr. Shaik Nafeez Umar and Professor B. Munaswamy who accepted our invitation. My deep sense of gratitude to our principal ma'am and vice principal who is a constant support and encouragement behind us. I convey my thanks to our head of the department, Dr. T. Meena Kumari, for being with us for successful completion of the webinar. My special thanks to my colleague, Dr. K. Srinivasulu. Without him, this webinar may be impossible. My indebted thanks to the technician, Subramanyam Garu, for giving this support from the initiation to the end of the webinar. Thank you all participants as a part of this excellent webinar. Thank you one and all. Sir, national anthem.
Okay, ma'am, I'm ready, ma'am. Participants, please stand for national.
Hello.
Hello, sir. Thank you, sir. Thank you.
Hello.
Madam, I'm starting national anthem.
Okay, sir. Okay, sir. Okay. Last. కట్ అయిపోయింది స్క్రీన్ రాలేదే మరి ఏం చేద్దాము
Wait, ma'am, I'm sharing the screen. Wait, ma'am.
Sir, 1 minute, Subramanian sir, 1 minute.
Okay, ma'am. Okay, ma'am.
Sir, ఒకసారి మునస్వామి సార్ కనెక్ట్ చేయరా ప్లీజ్.
Okay, ma'am. Ma'am, I think sir left the meeting.
Okay, okay, sir. ఇంకా కంటిన్యూ చేయాలంటే కంటిన్యూ చేశాను కదా ఆన్లైన్ లో మనకు డేటా అయిపోయిందా కట్ చేసాను
Okay, ma'am. Now I'm closing the session.
Okay.
Now I'm closing the session, ma'am.
But Janaganamana is not audible to us, sir.
I think some technical issue, ma'am.
Okay, sir. It's okay.